Okay, today we're going to take the derivative of the inverse hyperbolic sine function. So if you remember that the hyperbolic sine function was e to the x minus e to the negative x over 2, well, the inverse, it's not going to be as easy as taking the derivative of just a hyperbolic sine. Like we don't just take e to the x minus e to the negative x over 2 and then use the quotient rule, because here what we need to do first is we need to use the inverse relationship. So what do we know about the inverse relationship of arc hyperbolic sine x? We know that arc hyperbolic sine x equals y. Well, if it does, so we're going to let it equal that, right? We're going to let it equal that. Then the inverse relationship states that it's the same as hyperbolic sine y equals x. Much like with the trig functions, much like with the original trig functions, we use that same thing. Now, what are we going to do? We're going to use this. We're going to implicitly differentiate it, and then we're going to rewrite it into our original notation. So now we're going to use this, and we're going to take the derivative of both sides. So that's going to be dy dx of hyperbolic sine y equals dx by dx. What's that going to equal? 1, right? But the left side, the left side's a little more complicated. The left side is going to require a chain rule because y and x are not the same variable. Therefore, we are dealing with an outer function and an inner function. Now, the outer function is going to be hyperbolic sine x. The inner function is going to be y. Therefore, we're going to take the derivative of the outer function, stick the inner function into the argument, and multiply that by the derivative of the inner function. And what we're going to get is hyperbolic sine y by dy times, I'm sorry, is that correct? Is that actually correct? Let me write it down. Sometimes you have to go back to basics. I'm like doing it in my head, but actually, let's write down the outer function. I'm going to do f and g notation, f composed with g of x. What's our outer function going to be? Our outer function is going to be hyperbolic sine x, and it's going to be composed with y. Therefore, if we want to take the derivative of this, it's going to need to be, we're going to take the derivative of f composed with g of x. It's going to need to be the derivative of hyperbolic sine x, which is actually hyperbolic cosine x, but instead of x, it's y, and we're going to multiply that by dy by dx. Okay, so that's where I was trying to go in my head, and I just needed to write it down. So we're going to end up with that down here, hyperbolic cosine y times the change in y over the change in x equals 1. Well, now we're going to divide by hyperbolic cosine y because this is what we're solving for, right? So we're going to isolate that, and we're going to end up with dy by dx equals 1 over hyperbolic cosine y. How do we get that back to our original notation? This certainly isn't our end result, right? I mean, it doesn't look very good, and we don't want to end in math. We never want to end with something that doesn't look very good. We are going to use the Pythagorean hyperbolic trig identities, which we talked about in a previous video, and I will link it just in case you're missing that. But basically, the let me square this off so we don't get confused. This is not part of what we're doing now. Okay? Basically, what we're going to do is we're going to look at the hyperbolic cosine x squared minus hyperbolic sine x squared equals 1. We know that this is true. We actually calculated it in another video. Well, we know that we've got hyperbolic cosine y here. Well, for all intents and purposes, we can just write a y here. It doesn't matter what it is, right? The identity is true no matter what the variable is. So say it's y. It doesn't look very good, but you get it. If we isolate hyperbolic cosine y squared, and we take the root of the other side so we get it isolated, we'll know what this is, right? So we're just going to add hyperbolic sine y squared to the other side and then take the square root of it. And we're going to end up with hyperbolic cosine y equals square root of 1 minus hyperbolic sine y squared. But note that we know that hyperbolic sine y is x, don't we? So what that means is that this actually is the square root of 1 minus x squared. And so we're just going to substitute that into our equation right here. And we're going to end up with a solution that the change in y over the change in x, which equals the derivative of the inverse hyperbolic sine x, is going to be 1 over the square root of 1 minus, oh, sorry, it's not minus, it's plus. That's important. It's plus. See, you're adding to that side. I thought something looked wrong. Okay, plus x squared. And that is the derivative of the inverse hyperbolic sine function. And that's not as complicated as you might think it would be. You just have to conceptually understand it. So I hope this helped.